Now, the next topic from Unit 5 is elastomers. The elastomers, they show the property of elasticity, and some of the typical property of elastomer is they can be stretched many times their original length, and when force or stress is applied. So whenever we apply force or we apply stress to the elastomers, they can be stretched to many times, we can say 150% than their original length, and when this force and stress is released, they regain their original shape or original size. Now this 50% is not standard, it keeps on changing. So they have got a property of elasticity. Now the example of elastomer is natural rubber. The monomer or the polymer is polycis isoprene. The monomer is CH2 bond CH, this is double bond CH3 bond CH double bond CH2. This is 2-methyl 1,3-butadiene. So this is natural rubber. Now natural rubber is obtained from a plant Hevea bacillinacis. It is obtained from the latex of this plant. Latex is a milky emulsion. Now this latex contains 30 to 35% of rubber. Now in the process of extracting rubber, it is diluted. When it is diluted, the rubber left is only 15 to 20%, and then it is treated with acetic acid. Once it is treated with acetic acid, we get a soft white mass. This is your raw rubber, and then this rubber undergoes processing and we get a creep rubber and a smoke rubber. So we are not going into details of how this rubber is processed. Now this rubber which is formed has got some drawbacks. So drawbacks of raw rubber. So the raw rubber is not elastic in nature. Actually it is plastic in nature. Then it is very weak. It has less resistance, no resistance is there. Then the working temperature of raw rubber is between 10 to 60 degrees Celsius. If we increase the temperature, the rubber becomes soft, and when we decrease the temperature, it becomes brittle. That means when the temperature is decreasing, the rubber कैसी हो रही है? Hard हो जाती है. Then water absorption capacity is very high. It can be easily oxidized. So raw rubber can be easily oxidized in the presence of oxidizing agents. It is not durable, so it is less durable. Why? Because it can undergo air oxidation, and then it shows the property of tackiness. Tackiness means if we take two pieces of raw rubber and we press them together very hard, then the two pieces will become one. That is the property of tackiness. So these are all the properties of raw rubber, and these are the drawbacks. They are not very important. Not important means these are the drawbacks of raw rubber. Now these properties, they can be improved. So to improve the properties of raw rubber, we have process. The first process is mastication. In mastication, what we do is we apply mechanical stress. When we apply mechanical stress, what happens? This raw rubber undergoes fragmentation, molecular fragmentation or molecular degradation. And because of this fragmentation and degradation, the properties of raw rubber, all these properties, they change or they are going to increase, or these drawbacks are removed. So we can improve the properties of all these properties. The first process is by mastication. The second process is vulcanization. So by vulcanization, we can improve the properties of rubber. So what is the process of vulcanization? We take raw rubber. It is treated with sulfur at a temperature of 150 degree Celsius, and this is how vulcanization takes place. And what is the process of vulcanization? Sulfur is incorporated into raw rubber. So raw rubber में जहाँ जहाँ भी double bonds हैं वहाँ पे sulfur आके attach होता है. And when it is happening, it happens at a temperature of 140 degree Celsius. Now in place of sulfur, we can also take sulfur monochloride, or the process can also take place in presence of H2S. So that is how vulcanization is going to take place. Now if we take up the process of vulcanization, then vulcanization, to write the equation of vulcanization or the process of vulcanization, I take 4 monomers, CH3 bond CH double bond CH2 plus CH2 double bond C CH3 bond CH double bond CH2. Then again I take 2 more monomers of natural rubber. I am taking these monomers just to explain how vulcanization is going to take place. Now when these monomers, they are heated at a temperature of 140 degrees Celsius in the presence of sulfur, what happens is the rings, these monomers, they get joined. So, and in joining, this double bond will move to this carbon. This double bond will come between these two carbon as a bond. Then this double bond will move here and this double bond will move out. Similarly, this bond will come here. This double bond will come between these two carbons as a bond. This double bond moves here and this double bond will move out. So two monomers, they will get joined up. So the structure becomes CH2 bond CH3 double bond CH bond CH2 bond CH2. I am joining the second monomer, double bond CH bond CH2, and this. Then I write the second layer, double bond CH bond CH2 bond CH bond C CH3 double bond CH bond CH2. This. Now the sulfur which is here is going to incorporate or enter into the group at the carbon which is having double bonds. So when the sulfur enters here, the structure becomes CH2 bond C CH3 CH CH2 CH2 C CH3. This double bond is converted into a single bond, and then I write the second layer, CH CH2 CH2 C CH3 CH CH2. Now the sulfur is going to attach here. This is the process of vulcanization. So this is the vulcanized rubber. If the sulfur present inside the rubber is 3%, then that rubber is used in tires. And if it is around 30%, then the rubber is known as ebonite. Ebonite is a saturated rubber. So this is the process of vulcanization. Now we have synthetic rubbers. So this is synthetic rubber. Now the first one is Buna N. The second is Buna S. Then we have neoprene. And fourth is butyl rubber. So these are the four important synthetic rubber we are going to discuss. Now these two are almost same. One of the monomers is 1,3-butadiene. CH double bond CH2. It is taken 75%. The other monomer is CH2 bond CHCN. It is acrylonitrile, which is 25%. And when the two join, this double bond moves here. This will come between these two as a bond and this will move out. So the structure is CH2 bond CH double bond CH bond CH2 CH2 CH CN, and this is the repeating unit. When we come to Buna S, the first monomer is same, 1,3-butadiene, and the second monomer is styrene. In place of CN, we have C6H5. So the structure will be same as Buna N. In place of CN, we will have C6H5. This is also taken 75% and this is taken 25%. So one of the monomers of Buna N and Buna S is same. The first one, 1,3-butadiene. The second monomer in case of Buna N is acrylonitrile, and in case of Buna S it is styrene. Then neoprene. The monomer is, this is also substituted 1,3-butadiene. In place of hydrogen, we are having chlorine. It is also known as chloroprene. The difference between neoprene and natural rubber is, in case of natural rubber, in place of chlorine, we are having CH3 group. Now, when the polymerization takes place, this is the structure, CH2 whole N. So this is neoprene. The monomer is chloroprene. Now neoprene is of superior quality if we compare it to natural rubber. And if we do vulcanization of neoprene, it can be simply done by heating, or it can be done in the presence of zinc oxide or magnesium oxide. Then we have butyl rubber. The monomers are isobutylene and isoprene. Isobutylene is CH3, and this is isoprene is natural rubber. This is taken 98% and this is taken as 2%. When the two combine, we get butyl rubber. So these are four types of rubber. Now Buna N. Buna N is used as an adhesive. Adhesive is the use of any rubber. So you can straight away write down that they can be used as an adhesive. Then Buna N is used in tank linings of the tank, and it is also used in shoe heels. Buna S can be used in tire industries. It is used in shoe soles, and it is again used as an adhesive. Then neoprene can be used in shoe heels or shoe soles. It is used in gloves, and it is used in tubes which are carrying corrosive gases. So the tubes which carry corrosive gases, we can use neoprene. Then butyl rubber can be used as a fuel. It is used as a lubricant, and it is used in sport equipment. So this is about elastomers. So the natural elastomer is our rubber. And natural rubber, the monomer is cis-isoprene. It is 2-methyl-1,3-butadiene. It is obtained from the latex. Latex is a milky emulsion, and this is how the raw rubber is formed. Raw rubber is having certain drawbacks. It is plastic in nature. It is less resistant. It is weak. The working temperature is 10 to 60 degree. Water retention capacity is very high. It is easily oxidized. It is less durable. It shows the property of tackiness. So to improve the quality of rubber, we carry out two methods. The first is mastication. The second is vulcanization. In case of mastication, a mechanical stress is applied, and when we apply the mechanical stress, the natural rubber or the raw rubber undergoes fragmentation or degradation, which improves the properties of rubber. And second is vulcanization. What we are doing in vulcanization, raw rubber is treated with sulfur at a temperature of 140 degree Celsius. And this is how vulcanization is going to take place. The sulfur is incorporated where the double bond is there. Now, when vulcanization takes place, these properties of raw rubber are going to change. And what are the changes? The plastic nature is converted into elastic nature. The rubber becomes strong. The tensile strength increases. The vulcanized rubber is more resistant. Then the working temperature of vulcanized rubber is between -40 degree to 110 degree Celsius, which was 10 to 60 degree. Then water retention capacity of vulcanized rubber is going to decrease. Vulcanized rubber cannot be easily oxidized, and it is more durable. So the properties or the drawbacks of raw rubber are improved, or they become quality of vulcanized rubber. Then we have got synthetic rubbers. We have 4 synthetic rubbers: Buna N, Buna S, neoprene, and butyl rubber. The monomers of Buna N are 1,3-butadiene and acrylonitrile. Buna S is 1,3-butadiene and styrene. Neoprene is chloroprene. And butyl rubber, the monomers are isobutylene and isoprene. So these are synthetic rubber.